Okay friends, let's take a look at beginning with the circle, and we're going to more or less, based on this, by cutting up the circle, learn how to create a formula that represents the area of a circle. We'll suggest it in a way that is kind of convincing. So the first stage is, once you have your circle, notice I've divided it into individual wedges. I've done it on purpose. So after that, just take a circle and cut it like this. Look. So you cut the circle into two pieces like that. Doesn't even have to be too perfect. Then after that, trim away the excess on one side. I remember that for a circle, the circumference is 2 pi r. So that there will be pi r, right? Because that's about half a circle. So that distance there will be pi times r, where r is the radius right here. So that's one fact. And the other one would be, if you cut it this way, trim away that excess. And that's going to give us the second half of the circle. Let me do that. There we are. And that gives you this. So now you have two pieces of a circle. And for both of these, this is about pi times r, and this is also about pi times r for that other piece of the circumference, more or less, right? Now, to get this so that it becomes pi times r squared, you have to do something else. You can't leave it in this form. And the thing that we commonly do is this one. Take a look. Let me turn on the other light here also. I'm going to take this, and what we do is basically just cut off wedges. Look, like this. You can do this obviously with many finer wedges than these. This is just a place to begin to kind of get at the gist of it. So you'll see what I mean. And I'm going to repeat this for this portion and the second portion. Alright, so I'm done cutting up my circle into pieces. The next stage in the process is to basically glue these together back so that they form a rectangle. You basically take like a piece from here and a piece from here, you see? And then you just kind of lace them together, you see? Like this. And you can tell that this is already kind of forming a rectangle. See? Obviously, you have to tape this stuff down and so on. So I'm going to work on that a little bit now. So here are all of the pieces of the circle put together. Obviously, you would have to trim this to find a degree of precision by using smaller wedges, but the overall idea is still preserved, and the overall idea is pretty simple, right? Even though this looks kind of rough. It's still pretty much, as you can see at this point, forms more something like resembling a rectangle. And if you divided the circle into smaller wedges, then you could make a more perfect rectangle than this. So what's the general idea? The general idea is that now this right here, as you can see, roughly speaking, the height of this is about equal to the radius of the rectangle. So take a look here. Roughly speaking, the height of this shape now is r. I'm going to mark that over here. You see, whatever the radius is of the circle is also the height of the rectangle. And this quantity right here, from here to here, is now equal to about pi times r, which is half of the circumference of the circle. I mean, that couldn't just disappear after all, right? Just because you rearrange the circle in a different way. So this dimension from here to here is equal to about pi times r, which means that the area of all of this put together, the area of the shape, would be equal to obviously the base, which is pi times r, times the height, which is just r. So it would give you pi times r, which is pi times r squared, and that's it. So this is a kind of, handmade rough example, but overall you know how to do it by now. Just divide the circle in real life into essentially infinitely many, infinitesimally thin little wedges like that. And when you add them up this way, they'll make a perfect rectangle, and then you're going to get the perfect area of the circle. And to emphasize this point one more time, take a look. I'm going to take this, which is basically, as you can see, a rectangle, and I'm going to take a look. You see how they pretty much overlap? It's not perfect, obviously, right? But the big idea is now you can tell that the base of the rectangle is equal to half of the circumference of the circle, which is pi times r. And the height of the rectangle is about equal to the radius of the circle. And then if I took the circle and divided it again into infinitely many, infinitesimally thin little wedges and I stacked them out this way, that area would be about equal to the area of a rectangle, and that's it. Leave a like.